In this session, we want to consider UML activity diagrams. So I'm going to bring up my browser. I'm already in diagrams.net, and I'm going to begin with a class diagram so that we know what we're making activities or methods of. I'm going to bring a class diagram over here. And again, I'm not going to get too excited about the actual details of specific shapes and symbols and so forth at this point. It's kind of like code and pseudocode. The idea is to get the point across, and we can be more specific as we need to. Now, on the other hand, one of the reasons why the symbols and so forth are so specific is because the more detailed you are with the drawings, those drawings can actually be turned into code via another program. So we can do a lot of design work getting closer and closer to the code level, and it just becomes a balance of where you decide to draw the line. Anyhow, okay, again, all that's getting ahead too. I'm going to go with that bank account example. So I'm going to label this class bank account. And if we think about the properties that we have for a bank account, I'm just going to get rid of some of that stuff that I don't need. We said, there's an owner for the bank account, and there is a balance on the bank account. We saw this when we were looking at the Wikipedia article for class diagrams, just to put that in perspective. And so then we said that there are two methods or behaviors of a bank account. One is to make a withdraw, and the other is to make a deposit. Okay. So here's our general class diagram we're thinking of. Now, keep in mind that in the larger system, bank accounts don't exist in a vacuum. And so there would be other classes over here for the bank and probably customers and so forth, and all interacting together. But to keep our example a little bit simpler for the moment, there's our class diagram. Now what I'm going to do is make an activity diagram. And so generally there'll be an activity diagram for each one of the methods. So for an activity diagram, I'm going to have a frame first of all. And even though my class diagrams I would often put into a larger diagram with a frame, but this is the general shape for a frame. And I'm going to call this bank account. So I'm using the class name dot let's say withdraw. Okay. So this is how I'm visually tying them together that I know that, okay, this activity diagram is for the withdraw method of the bank account class. Okay. Now, what I'm also going to tend to do is I'm going to make that really small for the moment because diagrams.net sometimes editing things in the background and so forth gets to be kind of a pain. You'll experience that. So I'm going to make it small here, and then I'll drag it over my final shapes. Okay. Within an activity diagram, probably the most important shapes we need is there's an initial state. Okay. So we have a circle here. Again, I'm not going to get too picky as to whether it's filled in or not. Some people have, strong preferences one way or the other. But I'm going to say that, okay, there's our initial shape. And if you hover over these, it gives you an idea. And then this would be a final state. So visually, we know where this activity begins and where it ends. Okay. And it's going to be a flow, a procedure to get from where it starts to where it ends. Okay. And so, within here, I'm going to have where are actions, okay, that describe something happening, okay. And the other big shape I'm going to have are these diamond shapes whenever there's a decision to be made, okay. That's probably pretty much about it. And then in diagrams.net, if you hover over it, you'll see connection points. You get an arrow there. I'm going to draw that down and say, okay, we go from the initial position to this action. We can say, well, okay, what's the first action we want to do? Well, if we're going to make a deposit or a withdrawal, I guess I said withdrawal. Okay, so from the bank's perspective, and that's another thing too, is there's a perspective of the bank and there's perspective of the customer. We need to keep those straight. But from the perspective of the bank account has an owner and a balance, and you can't withdraw money from an account that you don't own and that you don't have money in. So the first thing to do, and the balance isn't higher than what you want to withdraw. Okay. So we can think about them. We can say, well, which is more important? Should you check whether the person owns the account first, or whether there's enough money in the account? Well, it doesn't matter how much money is in the account if they don't own it. So I would say checking the owner would be more important, and that should be done first. So what I'm going to do is I'm actually going to delete that and say, oh, before I take some action. Thank you for putting that in the wrong way. I want to make some kind of decision, and I'm going to say, I'll say, is this the owner? Okay. Now, I'm having it all in my brain because word it in natural language to start with. You don't be too worried about the specifics of the language at this point. Again, this is the beauty of designing in UML as opposed to trying to jump right in and write code where the syntax is critical. So I'll say, okay, is this the owner? Okay, we're going to have to talk about this, but okay, is this the owner? And there's basically two choices. It's either yes or no. In fact, all of our decisions are going to be yes or no decisions. Okay, and so then I would say, if it is the owner, then we want to check something else. Oops. We probably want to check the balance. And I'm not going to get too picky. If my OCD will let me to get over that. And then we can say, okay, so if I click on this, I can add some text and I can say yes. Okay, so is this the owner? Yes, we're going to come down here and say, is the balance greater than the amount to be withdrawn? Okay. Which is going to be yes or no. But before I do that, I want to come back up here and think about, okay, what if this is not the owner? Okay, well, in that case, nothing should happen and we should be done. So I'm going to say, oh, okay, in that case, I'm going to come down here, do it this way, and say that we're done. Okay, nothing happens. If they are the owner, then we check to see, okay, is the balance greater than the amount? And if it is, then we can go ahead and subtract from the balance and say, okay, the new balance is going to be the old balance minus the amount. Okay. And we can give the money to the person and all that kind of good stuff there. But again, we want to think about, well, what if the balance is not greater than the amount? Then in that case, we could just say nothing happens, but we might want to say, well, to be friendly, we should probably give some kind of notice. Okay, so I'm going to come over here and say, okay, if this is no, and I'll label this as my yes branch, it could be yes or no, true or false. Okay. If it's not, then we're going to say tell them the not enough. Okay. And then at that point we would be done. Okay. So both of those branches come down to the point where we're done. Everything ultimately probably will end up here. In fact, after we subtract the balance, we would also then come over here and say, okay, we're done. Now, there's a couple of things that you might be wondering about here, and that is like, okay, who's the owner? Who is this and who is the owner? What are the two things that we're trying to compare here? Okay. Down here, we're comparing a balance with an amount. Well, we know that balance is a property of the bank account class. So this bank account is going to have a value for balance, just like owner up here. This, when we're saying, is this the owner? The value of this is going to be the actual bank account object that called this. That's going to bear more discussion on that. But that one's defined. When we get down here, the amount isn't defined. And how do we know what the amount is? And one of the things is the amount is different every time you make a withdrawal, or at least it can be on that. So what we're going to do is we're going to say that the amount should be a parameter of the withdrawal method. So in my class diagram, when I say that a method has parameters, information, data that it needs to know to be able to do its job, then I'm going to put that in parentheses following the name. So I'm going to say amount. And again, that tells me that this withdrawal method needs to be given an amount before it can do its thing, before it can finish and do its thing. I'll never be able to say withdraw without saying some kind of amount. In the activity diagram, then, over here someplace is a parameter. Okay? And we typically show those in a box that's sort of half in and half outside of the diagram. I'm just going to get rid of that stuff to clean it up. Okay? So when I draw out my frame here around this activity, again, parameters are kind of hanging half in and half out because, again, that's information, data that's coming from outside of the method being passed into the method so that it can do what it needs to do. And the name of this parameter is going to match the name here where we use it. The sort of rule of thumb is whenever you see a name in here, if it's the name of a parameter, then we use that value. If the name happens to be like balance happens to be a property of the class, then we use that value. And finally, if it's neither of those, then it becomes what we call a local variable. We're going to make up the name here and use it. But yeah, that gives you a basic idea of all the shapes, the main shapes that we're going to use here. And now it's going to be a matter of applying these to more and more complex designs.